Okay, hi everyone, and welcome to this webinar on Norwegian UK collaboration on dementia and artificial intelligence. My name is Claes Pettersen. I'm the CEO of NORA. NORA is a Norwegian consortium for artificial intelligence. But today we have people here from the AI Mind research project. That's a research project led by Ira Haraldsen and an EU Horizon 2020 Research and Innovation project. And we have two speakers then from Dementia Platform UK. And the Dementia Platform UK is a partnership between 27 public, industry and third sector organizations with core funding from the Medical Research Council. We will have 4 talks today. Each will be around 15 minutes, and it's possible to ask questions along the way. So please use the Q&A option in Zoom. And here we can already see that we have someone testing it out. Yes, it's Ira actually coming in. Ira will also come in as a speaker. The 4 speakers today, I can shortly guide you through the program. 4 speakers. The first one will be Ainar. The second one will be Ira Haraldsen, both of them from the AI Mind project. And then John Gallacher and Emma Squires is from the Dementia Platform UK. So they will speak afterwards. And then we will at the end have a Q&A session. So please, in order for that Q&A session to be really interesting, we are dependent on good questions from the audience. So please prepare questions. And we will also take a couple of questions on the way in between the speakers. So that will be the program. And with that, I will introduce then the first speaker, which is Ainar, Senior Engineer Research Platforms at the University of Oslo, and his title is the AI Mind Platform on TSD and AI Tool Development. There you are, Ainar. Please share your slides and start your presentation. Thank you.
There we go. I hope that's properly visible now. Super. Thank you so much for the opportunity in this talk. As Claes mentioned, I'm going to be talking about the AI Mind platform on TSD specifically, and a bit about the AI tool development that we do in the project. So just as a preview, what I'm going to be talking about in specifics is the where on. So that's the TSD part of the presentation. Tjenester for sensitive data for those from Norway, and that's just translated as services for sensitive data. The how-to and a bit about AI and the motivation and a quick refresher for why we actually use it in AI Mind, and the what for, which is the actual AI Mind platform and the tools that we're developing for it. So first off, what's TSD? Again, Tjenester for sensitive data, or simply services for sensitive data. And we're a fully operational GDPR compliant virtual research environment for sensitive data. We're secure but versatile and adaptable to varying needs. We use remote login secured by 2-factor authentication with its own identity provider with mandatory access control. And it's provided and developed at the University of Oslo IT department. And some key numbers for TSD is we've been in production since 2014. We've got more than 10,000 researchers actually using it, more than 2,000 active research projects, and we've got more than 1 new project per working day for the last 4 years at least. We have upwards of 8 petabytes of sensitive data and more than 1 terabyte of daily data transfers per day. And we've got about 90 institutional customers, so at this point we're pretty fairly sized. And what does TSD actually offer? So TSD is a virtual research environment, as I mentioned, and it's specifically a platform to build your own infrastructure or just do research on your sensitive data, which usually means medical data a lot of the time. So you get all-purpose virtual machines, either Red Hat Linux or Windows, whatever you prefer. You get both. You get lots of software and support to actually do your research, and you can easily and securely import and export sensitive data via your own service portal, data service portal. We also have dedicated storage that is for this sort of sensitive data, and we've got data recovery snapshots, 90 days of backups on tape as well. In addition, for especially the medical people and medical corporations that we work with, it's important for a consent portal where you can have automated system to gather consent for different types of studies. We've got integrated data collection through something called NetSchema, which is a web form that lets you get answers from participants in, for example, a clinical study directly deposited into your storage space on TSD. And of course, very important for the AI side of things, we've also got on-premise high-performance computing cluster that is included and that you can use inside of the TSD infrastructure. Other stuff we offer that I'm just going to zoom through very quickly as a bit of a sales pitch. We also offer extra virtual machines and upgrades to those VMs. We give you access to extra PostgreSQL databases or servers, physical app nodes, data archiving up to 30 years after an ended clinical study, for example. We have API support for automatic import, export of data. So it's very easy if you build your software to interact with TSD to actually get stuff in and out of the secure environment. We have container support for stuff like Podman, which is Docker compatible, and Singularity. We also have sharing of data between projects so that if you have a collaboration with a spin-off project or other stuff, you can do that. We can provide custom hardware. We have advanced user support, and we've also got integrated AI-driven tools. That's all the rage and part of the topic as well. For example, we've got auto text, which uses the Whisper AI to auto-transcribe audio and video, which is also very useful for clinical studies. And outside of TSD, so not inside TSD proper, but at UIO, we've also got GPT UIO, which is from OpenAI, but with a bit of added privacy. And you're also able to run your local elements on GPUs within TSD. And we've got lots of other stuff as well. In practice, when you work on TSD, you basically just log in through a client, and then you're working on a virtual machine as you would. And then it's very much dependent on what you want to do. Maybe you're just a single researcher and you're going just to do your own little project, or you work in a big consortium, like, for example, AirMind, and you're building an entire platform on the virtual machines and on extra machines that you might want, or use databases or whatever it might be. TSD very basic architecture means that it's shielded from the outside, as you can see here, very basically illustrated. You connect from the outside through, for example, VMware when you directly connect, or with an app that you might have written that interacts with the API. And each project is shuttered off from everything else and only interacts with the bits that it needs to. So there's no chance for actual data leakage, and your data is secure no matter what you do. And as you can see here, for example, illustrated, you also have the HPC directly integrated with the TSD system. And so, as I mentioned, TSD in that case is the place to be. You can do anything from small-scale project to large-scale projects on TSD, and it keeps your sensitive data secure. Again, from individual researchers to large teams, and from simple scripts to building complex software platforms. And TSD is working with a lot of different and big partners, especially within the medical sciences and medical sector. So, for example, the Cancer Registry in Norway, the Norway Institute of Public Health, the Norwegian Mother, Father, and Child Cohort study, the Corona study, and lots of others with very heavy and large amounts of data that are based on TSD. But before we go on, and we will go on now to the AI bit in AirMind, what I often see is in discussions about AI, a lot of people are actually left with the question, what actually is AI in this context? And so I usually start with a quick refresher, what we actually mean when we talk about AI, machine learning, and deep learning. So artificial intelligence in general is just a catch-all term. We have to remember this for machines performing tasks that are usually associated with human cognition or sort of thinking. And that's basically any problem solving, and can be very simple from a linear regression. You just draw a line through a couple of points, or to something more complicated. And then we get to machine learning, which is a subfield of AI, and that's characterized by algorithms, either through supervised or unsupervised or reinforced learning methods, which make some sort of inferences from data and solve problems. So a bit more specific. And then even more specific, deep learning is a subset of machine learning, where the algorithms sort of attempt to mimic the way that brains process information through deep neural nets, hence the name. So machine learning, as I mentioned, are pretty much any algorithmic implementation of artificial learning and are often statistical in nature. And the question of what output you get from a given input is typically either knowable or at least more easily investigated than, for example, for deep learning. But again, deep learning is also machine learning. And on this right side here, you see a very simple example of machine learning, the simplest, as it's often called, the k-nearest neighbor, where you just look at a data point that you want to identify, look at the ones that are close to it and say, oh, whichever are the most close and have a certain type, then that's probably the one that you're trying to identify, that is the same one. And it can be as simple as that. Deep learning on the other side, here illustrated on the right, you've got an input layer, lots of hidden layers made out of different nodes, and you've got a lot of linear algebra going on between of those nodes, basically, with computations going on. And much simplified, it's just a subset of machine learning, and it sort of tries to mimic the neural network of real brains. So neural network learning, as a lot of you should have heard about by now, probably, especially if you're in this webinar. And deep learning consists of neural nets with multiple hidden layers, and hence the deep learning. It's a layered structure of algorithms. As I mentioned, you've got linear algebra going on in between the different nodes. And each node may represent a feature when you're actually trying to teach, as it's called, the deep learning algorithm something. However, it's very good to actually mention usually, it's very computationally expensive. So data must be passed through the neural net many times, because they are sort of slow learners before the actual features get set and you get something useful out of it. And hence why we've also got this push for bigger and bigger data centers, more and more GPUs and so on, which we're trying to push back with being a bit more smarter about our consumption and also energy consumption, therefore. So, and also in tandem with this, you need very large amounts of high quality data for your algorithms to actually get anything out of it because of this slow learning problem, basically. And then moving on to AI Mind and what this actually means for us, and very briefly summarized, and hopefully this will be expanded on in the next talk. Very briefly summarized just for the purposes of the AI bit. I can move this in case it's in the way. We have 1,000 participants with mild cognitive impairment enrolled in Norway, Spain, Finland, and Italy for this project. We've got 4 visits over 2 years each for all of the participants, following them over time. And we collect a variety of data, and that's the important bit for the AI side of things. So that's we get EEG, MEG scans, which are a big focus, biomarkers, big focus as well, and cognitive scores and social demographics as well for all of the participants. We're also, and then the TSD side of things, we're deploying a full AI Mind platform on UIOIT secure and GDPR compliant services for sensitive data. Here we've got secure and automated uploads, storage, the virtual machines that we built on, and the high performance computing that we use for the AI training and so on. We have quality assurance of the collected data. We have a processing pipeline, and that's also where we have the integrated AI and end user tools that we are developing as part of the platform. And then why are we actually using AI in AI Minds? I've already sort of talked around the topic, but how are we set to actually leverage the AI in this project? So basically, given our field, it might not sound as much with 1,000 participants, but since we've got 4 visits, we've got 4,000 readings and through time, and that's already quite a lot, especially given that we have a high volume of EEG recordings. So given our field here in the medical sciences, that's quite a lot of data given neuroscience here. And deep learning in particular shines when you combine different types of correlated data, which we have. And it can actually find patterns that a human may just not be able to because it isn't intuitive for a human. And additionally, our data is high quality and highly standardized. It's ethically collected and with strict consent from the participants. And again, we've got it securely stored and processed at TSD. So a lot of these sort of things that otherwise would stop a project in its tracks because you need to have all of these things in order for this sort of sensitive medical research. And to take advantage of this, we've got a unique mix of expertise from both neural and medical sciences, AI research, software development, ethical oversight, and a lot more. A lot of people go into this project. And AI Mind's primary goals, very much simplified by a non-clinician from the AI sort of viewpoint. We've got goal 1, which is that we want to find the underlying features in the brain that indicate whether someone living with mild cognitive impairment will actually progress to dementia. And we want to understand dementia at a more fundamental level so we can find treatments. Or very much simplified, what causes dementia, very ambitious. Goal 2 is be able to predict whether a specific person diagnosed with MCI will progress to dementia. And this will enable clinicians and people living with MCI to actually make informed choices about treatment options. Or will you get dementia? Again, very simplified. And these goals we have translated to specific AI tools that we developed for actually solving this. So for goal 1, we use AI methods, primarily machine learning, but there is quite a bit of overlap between both, to chiefly analyze our large data set of EEG and MEG brain readings of people with MCI. And then we want to find features in the recordings that correlate with people progressing to dementia. And then we want to analyze these features to find the actual changes in the brain. So going back to the biological side of things. And this is solved by what we're calling the connector tool. And this is aimed primarily at researchers aiming to understand dementia, its effect, and its effects on the brain. Goal 2, on the other hand, we are mostly primarily using deep learning, but again, there's overlap and we're testing out everything. And it's primarily trained, so it's trained on data from our EEG and MEG readings, cognitive tests, social demographic info, biomarkers, and we want to predict whether a given individual, so one specific person in our cohort, we check whether or not we can predict whether or not that person will progress to dementia or not. And we can also use insights from the connector, where we've used machine learning, which is a bit more tractable, as features that we feed into this tool. And we want, in the end, robust predictions with high accuracy and low uncertainty, of course. And this is the predictor tool. And this one is more aimed at clinicians wanting to actually provide a prognosis for their MCI patients in their practice, once we get there. And in the end, this will empower informed decisions by clinicians and patients about potential treatments or mitigation plans. And this is sort of the overarching concept of AirMind. You've got EEG data coming in from the left there. That's get fed into the AirMind platform, which is hosted on TSD, and where we have the AirMind connector, feed data in there, where you can identify disturbances in the brain network. And that in turn gets combined with the connector data that we've just gotten, the genetic test data, cognitive test, and is fed into the predictor, where you can then do individual assessments. And at the end, you can actually use it for prognoses. So the actual overarching take-home goals of AirMind are then basically that we want to have a deeper understanding of the brain and how it actually changes with dementia, and that creates opportunities for new research and insights. And in particular, we can uncover unintuitive and novel features in large domains of data using AI, which is simply not feasible by humans a lot of the time, and then continue on studying this by humans. And this is in the backdrop with today, we can only provide an impersonal statistical likelihood of about 50% progression rate from MCI to dementia within 5 years. And that's basically a coin flip that the doctor has to tell you, and that's not as good as you really want and not really a good prognosis, of course. And of course, in an aging population, this is going to just increase in importance. So in the end, we actually want to deliver a beyond the state-of-the-art diagnostic tool to predict whether someone will progress to a dementia diagnosis. Again, with high accuracy and high confidence in just days or weeks. And that means that we get opportunity for early interventions and a more targeted treatment plan. And thank you for time. That would be it. And questions are welcome.
Thank you so much, Ainar. Before we proceed with Ira, then I just want to ask you one question. You're operating within this services for sensitive data, TSD, which means your data is there, but it also means, I guess, that the compute is there. Have you? Do you have enough compute? Are you able to do what you want to do within that?
Yes, that is actually the big part of TSD, and we do have the compute there, and we do have enough of it. So as I mentioned, we've got an integrated high-performance computing cluster in conjunction with Sigma 2 resources as well that are integrated on premises of TSD, which means that your data, even if you want to do high-performance computing, training, whatever, it never leaves the premises of UIO. Which is the big bonus, because a lot of the time, yes, maybe you have sensitive storage or sensitive data storage, which is all well and good. But if you can actually do analysis at the same site, then you're sort of out of luck. Suddenly you have to share your data with another partner again, send it back and forth. And when you're on TSD, you just don't have to deal with that because you actually have the high performance computing on site. And that's also the big plus.
Excellent. And how is that collaborating? You showed the map that you collaborate with a lot of people from around Europe. Is that kind of no issue? Is it? Can they get access?
Yeah, that's so basically TSD is originally intended and mostly used by Norwegian researchers, or at least Norwegian research-led projects. But there's absolutely no issue with partners from different parts of Europe and the world to actually just become partners in projects. So we've got our own setup for foreign user registration. That's just a little bit more hassle for foreign users because you have to verify by passport and stuff like that, because there's no international electronic ID system. For Norwegian users, it's quite a bit easier because you can just use eID or bank ID, but you can definitely use these services as a partner if you're not from Norway as well.
Excellent. Thank you for that, and we will come back to that maybe in the discussion. And again, I will encourage the attendees to write in their Q&As, and we will take them during the discussion at the very end. But with that, we will leave Ainar for now and move on to the next speaker, Ira Haraldsen. She is the leader of the AI Mind research project at University of Oslo Hospital. And she will have a talk now titled The AI Mind Protocol, emphasizing the significance of the platform and its link to the UK collaboration. So please, Ira, the screen is yours.
Thank you so much for inviting us together. We appreciate that very much, and I will go in depth to what AI Mind started, in a sense, 4 years ago. And of course, the goal, as Ainar already mentioned, is that we will increase the personalized neurology assessment of people suffering from mild cognitive impairment. A little bit about myself. I'm a typical MD. I'm a specialist in neurology and psychiatry. I have lately then my research group directed into the research using AI methods, and on the course of this development, I discovered how important the activities are, and we are so lucky that we have several projects which we are coordinating today, and it gives us quite economic frame possibilities to do so. Ainar mentioned already whom we are and the TSD infrastructure, so I do not have to expand that one more time, but I would like to explore a little bit the industrial public-private collaboration possibilities which AI Mind enabled us to, and which are significantly, and I will also go in depth why I think it is strategically more important than ever before. Ainar mentioned we are observing 1,000 European citizens. We observed them for 4 times over a 2-year period. Why did we do so? Ainar mentioned as well that today it is a coin flip, 50-50% probability that you will decrease cognitively and will develop dementia, but the doctors can't say really for sure what it is, and especially if you are not at the stage of light dementia or serious mild cognitive impairment, then blood biomarkers, which recently enter the medical field, will not predict good enough. So you need additional information to predict reliable enough for medical science. And on the same other side, it needs to be simple, so that we doctors worldwide can apply those methods. We need to define a disease, in fact, biological. That is still not possible. It is done by conventional neuropsychological testing today. And we need, on average, in the European countries, highly civilized countries, 5 to 8 years to come to a diagnosis. And we will not be able today to initialize personalized interventions. And we will also, our exact diagnosis only get in countries with high technical development. So there is a need to revolutionize this field. Meaning we needed, and that was the real innovation in AirMind, a fully automated data collection. It needed to be affordable, it needed to be accessible, it should be non-harmful, as some medical techniques demands high resources at hospitals, and still it should be exact. So that was the idea, why using EEG, why using genetic text, protein biomarkers, and digitalized testing, cognitive testing. So we left traditionally methods waiting for patients at the doctoral office. We are looking for people self-screening themselves by 20 questions, which are available since other big studies like the finger studies, to screen and make it more likely that you do not only suffer from subjective cognitive decline, but that you have in fact some symptoms which would already be able to classify and find again if someone with specialist competence would investigate you. And that we are doing by QR codes. We give you access to that QR code, and then you are linked to the TSD server where your individual questionnaire is already stored. If you then score above a certain given threshold, then you will be invited for a polyclinic session. And there again, all the sessions have such QR codes so that doctors and other personnel are doing all the same. That includes as well the calibration of instruments and so on, so that we could do this as a multi-site clinical study, but using all for sure the same protocol. Here again, the standards today is that you will not receive at the first visit and diagnosis by your doctor, and you will usually wait on average 5 years, and then for sure it is too late. So the AirMind model will be able to identify a future risk within the next 3 years of probability that you would develop this disease. But this is not enough. If we would also succeed, we would also, we have to show that this is socioeconomically a benefit. It is not sure yet that all the introduction of AI and other technologies will really lead to an population-based better health situation in a given economic framework. So therefore, one of the activities of AirMind was also to predict how the costs would develop in such an endeavor as we are planning and doing. So that was also, or is still underway. So we had first developed a predictive economic model, and now it is on the health economist to show that we were right and that we in fact benefit from introducing AirMind as a clinical new method. But during the course of the AirMind existing, since last summer, I started to call these lectures also Mayday. Why? And unfortunately, I got more and more arguments for this positioning, as I think we are all talking about AI. We are also writing thousands of applications, but what are our societies really doing to make this transition happen and also to be seen in a global perspective. What should Europe's position within such an framework be? Because I don't think any longer that AI in itself will solve the medical problem. The medical problem of aging and the costs combined to it will not necessarily be solved by an algorithm. The problem is that we need maybe an interaction between human knowledge and AI, and we need to merge simulation technologies with AI to develop a virtual lab so that we could not only predict that you are developing a disease, but that we could also intervene hypothesis-based from other areas of knowledge in medicine and could trial and fail in the virtual lab by treating you in a virtual way with potential candidates of medication. What does that mean concrete? Concrete in MCI is a condition which is mainly with the waste of majority of cases is caused by cardiovascular and metabolic risks of other confounding and comorbid disease areas. But we are, as I mentioned, in a doctoral office, only able to try this hypothesis, give you some medication. We inviting you 3-4 months later, evaluating how you respond. This will not be possible with so many people in the queue in the future. We need to shorten these trial and fail approaches towards a virtual lab. But that needs that the countries and the European countries are not each country discovering the bike one more time and is establishing such methodologies, but that we would interactively, in a federated way, exchange where we have our strength and where we need other countries and other knowledge bases to support us. And as we started in AirMind with 8 European countries, it is sure that we can expand not only to 16, to all European countries, and we could make our AirMind platform available for the other countries after the project period in a federated way. And you should not necessarily always collect the same kind of data, but you could already use our algorithms on your data with your individual patients in the future. Another issue which is complicated and which we are not succeeding fully yet is the intersectorial and interdisciplinary approach. As I mentioned, the virtual lab will not be possible only in neurology or only in cardiology or only in endocrinology. We need not only the medical specialties to combined, we need also other sectors like the oil industry or other which have quite immense experience with digital twins and virtual twins to use their knowledge. So we need to become interactive, but that in a secure, cyber-secured way. And in the recent development of the politics, I would also suggest we need for sure a relatively sharply limited European market to do so. So that needs then that we communicate differently and that we combined our actions. And therefore, I'm very happy that the UK Dementia Platform is willing to interact with us, that we do this together in one language, in one communication strategy, and that we really come as soon as possible to a hybrid algorithm development, which would combine knowledge from simulation and AI. Today, these are completely different scientific research fields and hardly to work together. And why is this important? It is important as the real-world customer, as I call it, the patient, is collecting quite a lot of data already. They have consumer-based iWatches and telephones and so on, measuring their blood pressure and so on, which is fairly not really used in hospitals as an information source. And all this has to be integrated as we have in very short time to achieve more efficient health services. The state's budgets will explode in the healthcare sector, and it is no doubt in the given political situation that we would be able to expand our costs even further. The opposite will be true. We will get reduced budgets. And at the same time, the complexity is growing and the possibilities as well. Another European strong emphasis should be given on our trustworthy system developments, that we are offering transparently inside what we are predicting, how we are predicting, whom we included in our cohorts, how do we can guarantee enough diversity, and so that our algorithms would in fact also be correctly estimating the risk, for example, of dementia as well in immigrant population and not only in white Caucasians. So to make it to individual-based decision-making, we will need hybrids. We will need intersectoral knowledge to do so, to be successful and not needing too many resources to do so. We are sure in the long run we will, as citizens, be more satisfied by higher accuracy of our medical diagnosis and as well by a more efficient intervention. And although all this is at least in some pilots tried, there is still no virtual twin in neurology, as well no virtual twin, which is really combining other organs, like I mentioned, the heart or the metabolism. And if it is existing, it is more a curiosity in 10 or 15 cases or 40 cases, but that is not medically seen sustainable. So at least in our northern European countries, we have a lot of plans, a lot of research, but we are not very good in implementing it into our clinical everyday life. And that is caused mainly by a not sufficient infrastructure and a fragmented hospital system. Each hospital has an own server. And in the best case, you have some hospitals collaborating with each other, but that is not good enough. And the costs for establishing at each hospital everything, that will be completely impossible. So as I see it, the only way to go is a federated international collaboration within Europe with very strict cybersecurity measurements, which have also to be seen in a defense perspective, as of course these virtual twins could also be misused. This is one more time that we will also not be able to do so alone as the public healthcare sector. We will need private support, and we should also use from other industries their experience with such technologies. And I would highly appreciate and underline that in the collaboration between the UK and Norway within the European system, we should be able for the finest and best industries to work together towards what should I say, in a democratic way, organized, high sufficient public healthcare system, which can guarantee also political freedom. And to do so, we should also be open to develop on our data in collaborations, in hackathons, for example, problems together. We should do so intentionally just from the beginning when we start European projects, and we should not only we should systemize these efforts in planned actions, as I think we are talking more or less about the same taxpayers' money, which we are at the moment still misusing in a sense, as we are often repeating also research which would not have been necessary if we would had knowledge from all countries already combined, and would not have repeated also mistakes. And yeah, so I would one more time underline that I'm very happy that the UK is so closely collaborating with us, and that I think it is we are talking about European health, and in the longer perspective about also global health. Thank you so much.
Thank you, Ira. Excellent and inspiring talk. And just again, we will have more questions at the very end. So again, please use the Q&A button at your screen. But Ira, one thing, you were talking about international collaborations. You also have many partners. They have their data in their secure systems. But you are mentioning what you're aiming at is some kind of a federated learning scheme. So we are not, I mean, so it's the algorithms that will train in different countries within different secure systems, right? And then taking the algorithms back out. So data should not leave any country, or how do you envision that?
Yes, it would be nice if you, in a secured way, can combine your data or let them give the other systems access to your data, so that they could use your data and the algorithm could analyze the data sources from many countries. Because we know that we mainly with all algorithms are overestimating and overstressing the results, as they are coming mainly from research from very highly selected people. And it would be an advantage to increase the variance of data. And that is very important. And as we should also exchange our protocols, as I said, how do we access data, how we collect them, how, for example, this experience with the QR code, it's simple, but it should be used in all kinds of studies. It should not be an one day happening. It should, we should, our protocols, our data accessibility, and the exchange of algorithms should more unorthodox paradoxically happen in a way that we are generously sharing our knowledge, as we do not have the money to waste any longer, as dementia will be a long-lasting pandemic, and that could theoretically empty all our resources for health. But there are other diseases except dementia.
Excellent. Generously sharing knowledge, I guess, is pretty much what academia is all about. So with that note, we will continue to the next speaker, and again, post your questions, and Ira will also be able to respond in the session after all speakers are done. And next speaker is John here, John Gallacher, Professor of Cognitive Health at the University of Oxford and Director of the Dementias Platform UK. And he has the very short and good and clear title, which is Dementia Platform UK. Please, John, the screen is yours.
Well, thank you very much, class. Let me just check you can all hear me adequately, and you can see the screen. So that's a relief. First of all, I'd like to agree with Ira very much on the need to protect what you might describe as the international liberal order. I think that it's essential that we are really sort of clear-eyed about the risks associated with sharing highly sensitive and highly complex data and technologies. So absolutely support that. And I'm also extremely supportive of the need for us to work together across Europe. And it's a pleasure to notice that how similar in approach, although not necessarily in complete content, is the goals of AI Mind and DPUK. So with that being said, this welcome slide is not just a courtesy. It is actually an ethical statement. DPUK really does want to work with you. It's a part of our ethos to have high trust pre-competitive partnership. We treasure that, and that has been foundational to our success. So where there is opportunity to work together, then please feel free to contact us. And DPUK does look forward very much to working closely with AI Mind over the next few years. As we go into our renewal, which we, as you, must do from time to time, the emphasis really is on understanding and creating complex knowledge and how to use that. So, you know, this AI Mind is a fantastic partner for us. So this is an overview of DPUK itself. Basically, we're a tripod and our data portal, which is what I'm going to talk about most today, has focused, and I must say that the data portal's success is largely down to the effort and the persistence of colleagues in Swansea University. But Emma will talk about that in more detail following me. We have rapid data access, multimodal data. It's flexibly configured for different governance constraints. We try and curate the data so that it's research ready for third-party researchers. And because the data are complex and using our trusted research environment, our data enclave, our secure environment, whichever particular phrase you prefer, researchers do need to learn how to do this so that they don't waste computing resources and they don't get fed up trying to do things we can't allow, things like that. So that is our data portal, which I'll talk more about shortly. We also have a trials delivery leg, and that really is to try and streamline trials recruitment for early phase studies to date, and through our trials registers. So we characterize individuals so that it's relative, so that we reduce screen failure rates effectively. We then want to take these people into a trials site network. And the point of that is that you have the opportunity to standardize your assessments and standardize the governance arrangements in terms of legals and IP and things like that. And from that trial delivery, we have a study portfolio of around 30 studies, mostly academic studies. The third leg is our experimental medicine incubator. And here we're looking beyond A-beta and tau into, if you like, some of the systemic processes underlying dementia. So we have hubs for synaptic health, neuroinflammation, and vascular health. And of course, we just pick up studies along the way, which are, very interesting, and we're very pleased to host their data and support their data collection. So that's the overview of DPUK. It's a bit of a beast, but actually it works very well. And I think that's because we have a very good executive. And again, with our sort of high trust, pre-competitive ethos, that does lead to the genuine and generous sharing of ideas and data. Okay, so that's DPUK as a whole. Basically, the data portal has a fairly structured architecture. The details change in terms of what is best practice, how detailed it becomes, but more or less, this is if you like, the workflow. We take data in different formats. We do not, all our data is de-identified because that just helps for all the governance issues. So we take it in various formats. We discovered that basically a lot of research data, particularly population cohort data, is very poorly annotated and cleaned. So then we had to, if you like, invent a data curation level. So we had, and that meant we had to develop some data models, and this was a really difficult challenge because implicitly, every data model is optimized for a specific purpose. And unless that specific purpose is explicit, you can work your heart out on loads of things which ultimately aren't going to work very well. So after a couple of years, we settled on a data model which was for data discovery. And I'll talk about that in terms of our CSERV model later. So again, the curated data is available to researchers alongside the native data. And there are some specialists who much prefer to have the native data. But at least to have a reference curated data set means that the majority of researchers are using identical data, and that helps for replication as well as just developing the data descriptions for our data discovery tools. Then we ensure that it's interoperable, and I'll talk about this later, but basically it's a federation issue. This is increasingly important for all the good reasons that Ira mentioned. And the interoperability does require that we have by design trust, by design security, and by design transparency. So all of those things go on behind the scenes. Now, when you come to, if you like, the researcher interface, the researcher experience, we have a suite of data discovery tools which can be queried, and we are developing APIs for different pipeline purposes. And that relates to our data curation. So, for example, our Swansea colleagues have been working very hard on imaging pipelines in the same way that in Oxford, we've been working very hard on cohort data pipelines. So you can discover your data. We have about 85 data sets, including 50 cohorts. And you can look through those, select which cohorts are relevant, and then you can make an access request. Now, the access request is a standard one for all data sets. Basically, we're brokering access, so you can send us an access request for multiple data sets. Our electronics then distributes the request to the data controllers, and the data controllers read the access request, which is in a standard format, and respond accordingly. And we have a median response time of about 22 days, which I think is fairly good. We do triage the access requests because you'd be surprised how many people write in, give us all your data. And that doesn't go down very well, really. I think it disrespects the data collection teams, and it just shows you've given a lack of thought to your request, which doesn't give us confidence in granting access. So those failed triage, and we invite people to give a bit more thought and perhaps put in something sensible. So the access request is made, we broker it to the data controllers, they come back and presumably approve. Everybody then signs standard legal agreements. We find that the delay here is with the applicant university legal teams, not with us, and that we can also broker access to our clinical registers for recontact for clinical studies. That's a little bit more convoluted, but still, we have a full client management system in place. Then we have the data analysis. So once you get approval for access, then a project becomes live. We have a whole series of analysis tools. Basically, if a sufficient number of individuals want a particular software package, then we will put it on the platform. People have personal workspaces. This is very much like AI Mind. People will have personal workspaces, and the workspaces can be configured either for individuals or for consortia, and also through our federated software, we can receive containers and APIs. What we haven't put much effort into, but I think it's coming along gently, is a knowledge management system where we catalog. Well, we do catalog all access requests, but I'm thinking more of the outputs and the publications. That's very hard because people don't always tell you if they've published or if the project has gone into abeyance. But we're working on that, and I think with the next iteration of DPUK, then that'll be improved. So let's just look at the data flow. We will receive raw uploaded data in various formats with various degrees of annotation, various degrees of what we might call pre-processing. We're very generous in that. And for specialists, I think that's fine. If you're an imager, that's great. You just need the DICOM files or the Nifty files. You know what to do with them. But if you're not a specialist, and if you want to look at how imaging relates to survey phenotype, relates to functional genomics, etc., then these specialist raw data files are barriers, big barriers. So basically, we pre-process the data. For survey data, we process it to CSERV, image-derived phenotypes via various pipelines, and then omics phenotypes. We find that digital devices, it's hard, actually, because there are very few industry standards for data reporting. Private companies all have their own bit of intellectual property, which is fantastic for them. It's not very good for the research community, currently anyway. And we're also working on electronic health records. We don't have many of those. We don't have those at the moment, not directly, but we have our security and accreditation is in place. So we're negotiating with the NHS for access to those. And when that happens, because it will be a when rather than an if, that will be transformative. I think to have these outcomes on large population cohorts with virtual complete follow-up, by definition through the NHS, will absolutely transform the quality and the rigor of the science. So let's just look at our data model, our ontology for cohort data. Cohort data, if you think imaging is complex, then cohort data are complex. And the reason is that the data models change subtly, not just between studies, but within studies, across different waves of the study. So we do need a model which allows us to cope with that. And having a model which serves all purposes is impossible. We know because we tried it. So we ended up saying, oh, okay, let's be more limited. We have a model which allows data discovery. And then once you've discovered your data, each analyst can use their own work patterns and preferences, because that's what they would do anyway. So basically we have 18 themes, and within each theme, there are a number of domains, and within each domain, there are families of data types. And then with each family, we come down to the object, if you like, the variable. And this is actually a very straightforward structure. It's ergonomically quite usable. It doesn't require too much working memory, and it makes an awful lot of difference to the amount of time it takes to identify variables. So, for example, in a native data model, i.e., this is just the data received from cohorts. If you're saying I want to identify these 25 variables from 2 cohorts or whatever, however many number of cohorts, because all the data structures are idiosyncratic, it can take you hours per cohort. But if you know the CSERV data model, because you worked with it before, and if the data are in this model, i.e., you know the structure, you know the labeling conventions, and it's much, much quicker. I wouldn't say 15 minutes is necessarily accurate. I think that might be a slight shortening of reality, but nevertheless, it's very, very different. And you can imagine if you're looking at 20 data sets, the time saving there is on just having a simple, straightforward, but standard data model. Okay, so what are our goals for the data portal? Well, we want to improve discoverability and access. We want to improve the quality of the data so that we can deliver, or rather the scientific community can deliver, improved rigor. And we want to reduce the risk of data misuse and reduce the risk of public mistrust. And really, this is why we use a trusted research environment. And it's exactly the same as your TSD. And the idea is that people can put data in, they can play with it, but they cannot take the data out. And we don't have automated data file out procedures, but we would very much like to develop those. And maybe that's something that we can discuss. I think an underlying part of our zeitgeist, if you like, is that we would really like to democratize science as best we can. We would like to make a small contribution to this. Whether you live in, high-end computer Manchester or in rural Malawi, if you've got connectivity, you can connect to some of the best data in the world through DPUK. And that gives me a lot of satisfaction. I think also for early career researchers, sort of grumpy old men like me, we have our research networks. We know who to ring up and contact and discuss ideas with. But if you're in your sort of middle 20s or early 20s, you're just embarked, where can you get hold of these data? Well, actually, you can get hold of them through DPUK. And for most analyses and for most data sets, it's cost neutral, it's free at point of access. And again, I derive great satisfaction from that. Whenever we put into MRC for our renewal, one of the questions is, how will you make this sustainable? And I must be honest with you, I think that I try and fudge it a bit so that I don't have to charge early career researchers for access. And I'm going to continue that for as long as I possibly can. So does it work? Does it work? Well, here we are. I don't think we're in the rarefied atmosphere of AI mind, I must be honest, but nevertheless, we've over our 10-year period, we've had 2,200 access requests for 85 data sets, and we have over 1,200 users in 43 countries. Now, not all of these data access requests are successful, but let me think now. I expect about 55% when the processing of the 6.65% is done will be successful. But those are usually down to very poorly presented access requests, as I said earlier. When somebody says, give me all your data, we gently decline and ask them to rethink. What I do like is this median decision time of 22 days. Sometimes it goes down to 21. But it's really exciting that we can turn these things around so quickly. Again, the idea is to encourage and facilitate and support researchers in accessing data. Our data access applications go up each year. It went down in 2020, but that was COVID. But since then, they're going up annually. And I expect that to continue. Mostly it's academic users, but we do have some industry and some government users as well. On the left there, you can see our most popular cohorts. And it's interesting to look at who goes for which cohort. Usually there's about if you stick in a data access request, normally it involves more than one cohort, 2 or 3 cohorts. As you can see, Whitehall, Brains for Dementia Research, ELSA, and Memento. I really do have a lot of time. I respect very much the Memento cohort. It's very, very informative. So what is the future? Well, the future for us, I think, is enabling multiple research communities. To be fair, and I completely understand this, if you take traumatic brain injury and you have a really good collaboration going, you don't want to lose your identity within the big beast of DPUK. I mean, it doesn't help you. So what we do now is spin up, as the term goes, all our resources to give the traumatic brain injury community its own identity within Dementias Platform UK. This is very inexpensive for them, and they get and it's also very quick for them. It's a very low risk solution because it's a mature solution they're being given, but they get all of that, but they have their own identity, their own palette, whatever they want to do. All we would have is DPUK as one of the partners. Apart from that, nobody would know that we were involved. And that's been very successful. So we're bringing those, we're expanding the number of hubs that we have. And we also bring specific data modalities together because that enables experts within those modalities to access the data more easily. And I think the big growth area for us has been imaging. It's been extraordinary how the imaging community is gathered round and, and exploited this opportunity. So the next angle for us, or priority for us, is metadata-led and data-led federation. By data-led, I really mean what you're doing is creating a governance-neutral data lake where people can put their data in. I'll go into that in a bit more detail shortly. But you also have to have the metadata-led federation, which is the pattern on the left, the mesh topology. And because I think for most sensitive data, and particularly where there are issues of sovereignty involved, that's all that's going to be allowed. But the question is then, how do you allow it? And what we'd like to get to is what you might call a mesh model, where all the different platforms are operating as siblings rather than a sort of a parent-child model. So the parent-child model is, if you like, slightly on the right, you've got a submission layer, and that submission layer is operated by one platform on behalf of all the other platforms. And I think I would prefer personally to go to any platform being able to submit the query and then allow that to go to the other platforms. And in an updated version of this on the right, I'm looking forward to having AI Mind in the future. So the future is also, I think, linking molecular data to health data. So we would have molecular and cellular research data early on in, if you like, the pathology pipeline, neurodegeneration pipeline. And then we have the National Health Service data in the UK, very, very wonderful, but very hard to access. And even yesterday, I think, or the day before, the government announced a new initiative to make it more accessible. Whether it does or not, time will tell. And then we would like to use DPUK infrastructures to bring those two together. Now, this is where the governance neutral pop-up TRE comes into it. Clever colleagues in Swansea have worked out a way of creating a trusted research environment which can be generated on a per project basis, and it includes full governance of all the other platforms involved. So what that means is that the data conform to your government's needs, whoever you are. But it also gives you the opportunity to switch the whole thing off if you're dissatisfied with how it's operating. So basically, it's taking away the need to have data in a specific box on a specific site as the governance constraint, without changing any or loosening any of the governance requirements. And I think this is a really neat solution. And we will be developing this in the next phase of DPUK. So let's think of some lessons learned. First of all, we really do try and be user-facing. It's all very well me waxing eloquent, but unless the users understand and find it helpful, it's just a waste of money. We have needed to be persistent, because there are professional issues, there are governance issues, there are technology issues, they may be simple conceptually, but practically they're rarely simple, and they need to be addressed by persistence. We focus on providing specific solutions, but we do our very best to design them in a way that they are generic, so that we can transfer learnings from one area to another area. This has been particularly helpful in the data model and also in the data discovery tools. At each stage, we look for opportunities to standardize and streamline. And a good example of this has been the data access request. When we began, each cohort had its own data access request form, and they were all slightly different. But they all had the same elements. So after a year or two, we plucked up courage to say, well, what we've done is reviewed all of your data access request forms. Here are the common elements. Why don't we use this one form? And for many cohorts, that's exactly what they've done. Because I think frequently our form is actually more efficient than their form, only because we've designed it later on in the process, whereas frequently in a cohort study, the data access form was designed 10, 15, 20 years ago. Accept incremental improvement. And I think I get very frustrated at the slow pace of development, but every little step is a win. So I think that's helpful. Wherever you can automate, this data management is so labor intensive, automate. And then we make a point of trying to think strategically. And this sometimes is a challenge, because you can be 5 years ahead of the field and get absolutely nowhere. And then you realize 5 years down the line, it's being done by somebody else. But never mind, it's all in a good cause. But I don't think there's any really justifiable reason for not doing one's best to think strategically. So I think that's probably it. Oh no, here we are. Finally. So what we've tried to do is develop a framework for complex science. And we've worked out that basically we're trying to encourage collaboration. We're trying to encourage data access, trustworthiness, user-led development, and optimal motivation. But these things are not obvious. So for collaboration, the real issue here is minimizing the transaction costs. For rapid data access, you really need to know what the property rights are, and those are very unclear in academic data. Trust by design, I mentioned. User-led development constrain and coordinate innovation. So, for example, it's wonderful to have the freedom to use 10 data models. It just is useless. Sometimes you just need the 1 or the 2 data models. And encourage, create trust, create best practice, share your ideas. So as somebody has said, it's not about the technology, it's about the people. And we think this is really important, and hopefully it's a bar that we try our best to reach. Thank you.
Thank you, John. That was inspiring, and an inspiring end of the talk. It seems to me that you're not only kind of creating a platform or a framework, but also a community with values and so on. And just one short and quick question from me before we go on with the next speaker. If I understood you correctly, could anyone apply, and what's to kind of get access to some of the data and so, and what's the criteria of getting access? How do we, if I as an individual researcher, could I apply, and how would I go forth by doing that?
Well, actually, Emma is the best person to answer that question. The answer is yes, but if you want detail, you need to ask Emma.
Excellent. And with that transition, I think we can just move on then to the next speaker, and we can come back to some of these questions also. And again, audience, please write your questions in the Q&A. Use the Q&A mechanism here in Zoom. Next speaker is Emma Squires, Head of Program Development for the DPUK Data Portal. And again, a very clear and excellent title, the DPUK Data Portal. Please, Emma, the screen is yours.
Wonderful. Thank you very much. And thanks for inviting me along today to talk a bit about the DPUK Data Portal. I think John has given a lovely overview of what we've been trying to achieve. And I'm going to try and take some of those aspects and go a little bit deeper, talk about those pipelines that he mentioned very briefly, and a little bit more about the federation work that we've been doing, and also a little bit about the hubs that we've established as well. So I will share my screen. Fantastic. Okay, so this is just another version of the little dashboard that John put up earlier, and it gives a lovely indication of where those applications are coming from. We accept applications from across the globe, and we do get applications from everywhere. So I do love the fact that it's a very global platform. We also, those 50 different cohort studies that John mentioned, we've got 85 data sets that a part of those cohort studies that we provide access to, but they cover 3.5 million people. So the amount of data that's available via the platform is growing every day. The number of researchers that we've had in total, about 1,800, and they're doing some really great studies on our platform. We are what we call a trusted research environment. There's lots of other names, SDEs, and I believe there's a different name in Europe as well. But basically, we're just a very safe and secure infrastructure for providing access to data for researchers. In the UK, there's been a guidelines on how to be a good and safe trusted research environment that's been called the 5 Safes, and it really does lay out like how to make sure people are safe when they're accessing the data, and develop that framework for doing so. So as John said, a super secure environment, data never leaves. We allow researchers to access the data in the same way as Ainar was saying with VMware Horizon. They have a virtual desktop environment, and they point to the servers with the data. They have access to the data they're approved to have. and they can do their analysis. We vet people as they're coming in to make sure that they are bona fide researchers, they belong to academic organisations or collaborations, and they have to sign a data access agreement that lays out what they can and can't do with the data, and that they must only use the data for what they've specified in their application form. So, we have that agreement with them and lay out the expectations that we have of those users. We also, as John said about our projects, those go through lots and lots of triages. So we make sure that those projects are safe and robust and in the public interest, so that whatever's happening inside our trusted in research environment, we know are effectively safe projects. Our safe settings are we run on UK CERP infrastructure. So they're our infrastructure supplier. They are fully ISO 27001 DEA accredited, cybersecurity is accredited. If there's an accreditation, they've got it. They provide infrastructure for over 28 trusted research environments across the globe. So we know we've definitely got safe settings. We're also fully ISO 27001 accredited for our data management processes as well. So we really take it very seriously that we are following these legal obligations and these good standards to make sure that that data is kept safe. We also safe data. We only give out the data that's required for them to be able to carry out their projects. And when I say give out, provide access to the data to do their projects. And again, we make sure that that we can filter that data, so all our data gets tagged, particularly our neuroimaging data and our genomics data. We don't want to give them all of that data for that data set, so we make sure that we're only giving them the structural MRIs or the GWAS data, so they're getting only what they need for that project. We also, as John said, de-identify all data as well, so they're only accessing de-identified data. We also do an egress process as well. So they work inside this very secure environment. They got all the software they need, but when they need to take the results out of the platform, they will request a file out, we call it. And 2 data analysts will look at that file out and check that there's no row level data or outliers or anything that could potentially be disclosive out in the real world. And as John said, this is very labour intensive. So yeah, any processes that could speed that up, we're very interested in. The past 10 years have been very focused, well, the last 4 years, I think, really, we initially started off bringing in that survey data and making that available to researchers. But then it's very much about augmenting that data and bringing in data that complements that to allow researchers to analyse it. So there's been a big focus on bringing in neuroimaging and genomic data into the portal that's associated with those cohort studies. And it just gives a much richer environment. And by bringing those types of data in, we found that people wanted to come and do AI model development. So that really pushed us into a new realm. The governance alone was very challenging, but also being able to make sure that that data is clean and ready for AI analysis is a big part of what we do as well. John already mentioned the data discovery tools, but the researchers being able to find the data they need to be able to carry out this study is absolutely essential, just to be able to get the right people to be doing the clever science that we need. We need them to be able to know whether their project is feasible. And we've also put a lot of money into the big data analysis environment. As Ainar said at the beginning, having a HPC cluster inside the trusted research environment. HPC clusters, by their very nature, are not that secure. We do not want our sensitive, secure data on some node of a HPC cluster. So making sure that we develop that HPC cluster inside our environment was really important. And the researchers are able to access that and do that bigger, larger scale data using these more complex data types. So neuroimaging data has been a real focus. We've put a lot of work into this, and my colleague Lewis has led on this. We have pipelines as the data comes in. We will do data quality checks, check metadata matches the data, but we will also standardize it to BIDS format. We deface the images to make sure they're anonymized, and then we will tag them, as I said, what types of scan they are and anything else that we can filter on to be able to give those data sets out. And as John said before, sometimes, analysing raw imaging data is a skill. So we will also take those images, we will pre-process them, harmonise them and generate image-derived phenotypes that we can then put into the phenotypic data, and really reduces that barrier for the researchers to come in and use that data. Our genomics data is starting to build. We've got, I think, APOE status for 100,000 study participants, and we've got GWAS, VCF, various types of genomic data for 15 of our cohort studies. A big project was undertaken in Cardiff to generate polygenic risk scores. So I think it's about six of our data sets have full polygenic risk scores on them as well. We are looking at pipelines now to be able to bring that data in more efficiently, and to give researchers tools to be able to analyse that data, and pipelines to generate other derived phenotypes as well. This is a quick snapshot, and I think it nicely shows what John was referring to earlier about our curation for the data discovery tools. By grouping the variables into the ontology, it means that we can give a snapshot overview to a researcher of what type of data is collected, and then they can make a good well, they can go and explore that data and make sure that they can find all the ones. If they're interested in family disease history, they go find all the family disease history data sets, and they've got a good start. If they click on any of the cohorts in the thing, they take to a data dictionary level. And if they want to go even deeper than that, we have an explorer level tool that allow them to be able to filter by BMI and physical health and other variables to be able to see what kind of data is held within the platform. Very similar to we've also got Windows desktops and Linux desktops, and we've got the HPC cluster inside, and we have preloaded software as well. We also have a filing system, so researchers can bring in data, they can bring in software to be able to use in analyses as well. Federation is our big focus, and very much something we're looking forward to in the future, to build on what's already been established. Here in the UK, DPUK has been one of the first implementers of being able to put in a federated solution to allow access to DPUK data by ADI, Global American Initiative, to be able to show proof of concept that these can be done. So we are interested in working this. Again, our infrastructure supplier, SERP, is developing a multiple federated solutions as part of its funding, but these will be available to us as well to be able to implement. So we've implemented the prototype federated solutions. We're really excited to see what these bigger, more exciting solutions will be as well. There are two products that are being developed for federation that we will be using. We have deployed both in DPUK already for particular use cases. And these federated solutions are very different. So DFX is very much about that. When you create a query, you put it in a container, and then you fire it off to each of the trusted research environments. It runs its analysis, and then it returns the results. You can then, as we do, we would hold it in egress. We review that file out, and if it's safe, we allow that results out. So this is, very much, it's very difficult for the end user. You can't see the data, so you're working off metadata. It's great for the data provider because the data's safe, nobody's touching it, the data's not moving, the queries go into the data. But it's quite difficult for the end user to be able to, normally you're talking GraphQL or some other form of language that needs to be used. It's a big barrier to the research. So the teleport is different to that in that it's referred to as a pop-up TRE, in which it pops up between two trusted research environments and the data moves to that trusted research environment. But both TREs have full governance over the TRE in the middle. So researchers can then go into that TRE, and the data is moved into that TRE. They carry out their analysis. When they're ready for the results, both trusted research environments review the files and decide if it can be released or not. If one says no, then the data's not released. The files are not released. So it's having that shared governance over a central trusted research environment. This is much easier for the researchers. This is how they work normally. They go into an environment, there's the data, they analyse it. It's a lot more difficult in the governance. All our data deposit agreements say that the data will never move. Well, the data's moving, but is it really moving if it's in still within your governance. So there's lots to be explored there. And we have managed to set up a pop-up TRE between Dementias Platform UK and the Sale Data Bank, who we work very closely with. The Swansea team work in the same building as the Sale team. So it's a lot easier to have the trust and the governance in place when you're neighbours. So how that works on a bigger scale would be interesting to see. With the multimodal data coming in, we had lots of requests to start doing artificial intelligence models on the data. And I am so glad Ainar came in first and went and explained the AI and the deep learning and the machine learning. So that's cleared that. I don't have to do that, which is lucky. But it's still those models being developed. If they request them out of our environment, we've now got a privacy issue. Are they safe to release? Is there a chance that they could be reconstructed and the data could be derived from them somehow? So we've done an awful lot of the governance around how we can allow AI models to be created inside our TRE, but also what happens to them when they want to be taken out to be trained on other data, or other people come in to try them out. So we've got 3 different models in which we can we can host it inside our TRE, and people can come in and use the model, or they can bring the data in and train it inside there. Or we can do it by federation, or we can allow deployment. But then we're talking lots of agreements in place and legal responsibility, and what if something goes wrong. So the deploying it is the last choice, really, because it is quite complicated. We're also looking at making our data ready. So if you've got data collected from one place, all nice through the same forms, then you've got nice standardized data already. But we've got data come from in 54 different cohorts. They're all in different formats. They've all collected different types of questions. They've all got, even gender is either 0, 1, M, F, male, female. Everything is different across these. They're quite a challenge, as John said. So we are looking at pipelines where we can clean that data, make sure there's no missingness, standardize the variable names, also like the versioning control, annotating that data and documenting it so that we can bring that data together, creating a really rich resource for researchers to come in and to be able to do AI analysis on. And we've done a lot of work on this on the neuroimaging. It's a lot easier to harmonise images than it is to harmonise really messy cohort data. So we're making lots of progress on our imaging data as well. But this is definitely a route we're heading down, and work is already underway. John briefly mentioned hubs, and I'll talk about those quickly. The work that has gone into DPUK, I think people think running a trusted research environment is very much about having the technology and the security. I think the majority is having the governance and the processes and the people and the resource, because it is really consuming in those areas. So hubs were developed because, in the UK, they don't want to fund the infrastructure again and the processes again and the people again. So hubs allow people to come in and retain their identity, like John said, but benefit from all those knowledge that over the years, over those 10 years, and these really mature processes that we've developed. We've already got hubs for traumatic brain injury, motor neuron disease, there's stem cells, tissue. So the hubs are being taken up quite a lot and being used. We're doing a lot of work in synthetic data as well. Even when we're talking about the federation, the governance around that federation needs to be really well established. If I'm attaching to AI Mind, you want to make sure that I am going to be doing exactly what I'm going to say I'm going to do. So having that governance in and making sure that the governance people are all very calm about what's happening and there's no GDPR breaches is really important. If you can do that on synthetic data first, people are a lot more calmer about being able to have a go, establish it, assess the risks. So my colleagues in Swansea have worked on generating different fidelities of synthetic data for different use cases. And we'll be able to use this synthetic data for researcher training, AI model development, and for federated testing as well. And this is the data portal team in Swansea. I just pop this up. There's a big team. There's a lot of work that goes on, and they are a fantastic team to work with. And that's the end of my presentation.
Thank you so much, Emma. Excellent. If anyone has any questions for Emma, we can take them now. But I think I would ask you, all the presenters, to turn on your camera so we can all be here for Q&A. Excellent. So again, please, attendees, if you have any questions, this is the time to post them. If not, I will still start. I mean, you touched upon the future, some of you, and Emma, the future maybe even larger data sets. You talked about multi-model models, which means even more data. And it's typically then also requires larger compute. How are you set in the UK for this development?
Yeah, so the compute-wise, we are really lucky with UK SIP as an infrastructure because they really deploy in a lot of scalable, highly available compute power. So we're underpinning our TRE with Kubernetes to allow us to be able to scale and pull back when we need to, so that we're only using, if you don't want to be running a full large scale compute all the time, it's really expensive. So if nobody's using HPC, we want to scale it back. If nobody's using the GPU cards, we want to scale it back. So having that flexible compute to be able to move through is really important. And they act as a cloud, private cloud in themselves, so they have that server capacity and scalability that we can just reach out to and use that when we need to. Excellent. By the way, on the Norwegian side, is this similar, or do you see any? How is the future looking, Ainar or Ira, when it comes to both storage and not to mention the compute facilities within TSD then?
Well, within TSD, we're actually currently, during the summer, we'll be upgrading the resources a little bit more, integrating more deeply with Sigma 2, for those who are familiar with that. That's going to be more deeply integrated and made as more of a whole solution. It's been a little bit more two-parted within the system. And at the moment, I mean, we have it on demand, and we're currently meeting the expectations and the needs of the users, and we're upgrading as we need it, so to speak. But at the moment, we have enough for the needs of TSD. But of course, we are expecting the needs, especially in terms of GPUs, as generative AI especially is something that's more requested, where you need the actual GPUs quite a bit more. As Emma mentioned, synthetic data is becoming more important, and that's also something where the generative methods are, that's what you need for the actual synthetic data. So it's becoming more important, but at the moment we're scaling as needed, basically.
Sounds good. So the future is bright with respect to that. Federation has also been mentioned by all of you, and also governance challenges. Maybe you, Emma, to the governance challenges. What has been the challenges this far, and again, what's the future there?
Well, I think, like he was saying, it's very much about opening up this data access. We've kind of built silos, particularly within the UK. We have data inside TREs, and we build castle walls. We make them very secure. Nobody can come in, nobody can touch it, because this data is that only approved people come in. And now we're talking about punching holes in the sides of the castle and putting pipelines between us all. It makes the governance people really, really nervous. And my colleague Fatima did a piece on being able to just quantify what the ask is. Would there be review of those file out results, or would you have to trust that the container had worked, or would data providers still review the applications, or would there be, I don't know, aggregated results? These different levels of working across Federation, and looked at having a governance framework around each of these to start talking about the processes. And I think if you've got something to refer to, you can start then testing it with people who you're looking to federate with, and find out, oh, this is where I feel that we would fit, or this is where we're comfortable, or the nature of our data means that we wouldn't be able to do this. And then you can start really building on that governance framework and ensuring that it's in place to allow these things to happen. Because technologically anything's possible, but whether the legal departments of these organisations will let us is a different matter. So it is important. John.
Yeah, John.
Yeah, class. Just to reinforce Emma's point. The UK missed a very big trick about 5 years ago in letting everybody have a TRE. And what you end up is, rather than bringing data together in a secure environment, you're separating the data in multiple secure environments. And if Norway can avoid that, that would be a fantastic strategic step, because we are now unpicking our lack of leadership in terms of creating a good, functionally good data environment. Okay. Just on another issue, people think that the secure data depends on where the box is, and I just don't think that's true. But persuading my research colleagues that actually secure data depends on the governance and who's got power over the box, over what's in the box, not where the box is proving a very big ask. So if you can manage that as well, oh, wonderful, wonderful.
This was
But unfortunately,
Ira, please speak on the.
Unfortunately, we are not so sure that we will succeed with this effort as well, because it is critical. The curation is critical. The basics, control checks of data quality, curation, the very simple sewing equipment, that is the essential. And then, of course, in our nation with 5 million citizens, it is ridiculous thinking about different boxes.
Yes.
But it is in fact, there are several different boxes, and then the major take-home message for me is how essential it is, John, to talk to the NHS and to talk to the Norway 4 health regions and the organization within these 4 regions, because we can continue to research the one and the other. The proof of the pudding is in the real world patient. And if we are not soon showing that our efforts show any benefit in the everyday clinic, if we are still needing 5 to 8 years for diagnosing dementia, then we are failing. We have to showcase that it is in a clinical context possible.
Yeah.
And therefore, I am a little bit concerned about we can strive to make it better, to let the Dementia Platform in the UK interact with AirMind and so on. This is all nice, or with all the other e-brain health data banks. The discrepancy and the gap between clinics and research is growing, and this is not good.
But what annoys me is that it's a governance problem, not a technology problem.
Just right. It is a governance.
I echo the same thing again as John and Emma have mentioned. The technical side, while it isn't simple, it is sort of figured out. Like, we know how to build these secure systems like TSD and over at in the UK. So these systems are up and running and they work. And I think, as John also said, the problem is more when people talk about federation, like the problem is, I think, the fragmentation is more of a problem than trying to do good federation. Like, federation is well and good, I think, especially across borders. That is very important, where you want to share data, where you have to silo it in a way because the national interests and the national laws are different. But within nations, it's definitely more of it is important to have more of a centralized thing, I think. And TSD, of course, is aiming to be a very general service for sensitive data that services everyone. As long as they have sensitive data, you are welcome at TSD and you can set up whatever you want. And the challenge is more in setting up the software and platform that you want. And there, the sharing and federation of solutions, I think, is the challenge, and that we also want to build on. But Ira, you have your hand up.
Yeah. What we need is a politician or a government member who is interested in our basic stuff, curation and in pipelines between the data banks. And how do we do this efficiently? And Klaus, you are a politician.
Well, unfortunately, a little bit, and no, but you're perfectly right, and also, I mean, federation is in a sense a consequence of fragmentation, right? So we need to complicate things necessarily. I do think we have at least less boxes in Norway, maybe than in the UK, and I don't know, John, if you have been able to kind of turn that direction around. Do you have more or fewer boxes these days than a couple of years ago? Are you still on the fragmentation process, or are you trying to kind of defragment the data banks in the UK?
Yeah, I think we've slowed down the fragmentation. The research councils are much more careful about funding TREs than they were. So that's good. I also think the government is more concerned about accessing health records, about enabling access to health records. And just 2 days ago, they made this great announcement about a big centralized system in Cambridge, which is wonderful. But it's going to take years. You know, they've got to build it, they've got to work out. It's going to take a long time. So I think we are several years away from an efficient linkage of research data and medical outcomes.
Yeah. And I could also say, I mean, also in Norway, we have tried to unite in a sense. We had this big project called the Health Analysis Platform. This has not at all been a success, so they had to cancel it. So we have tried to kind of unite the sources in a way and build a common platform. But this is also obviously a very complex task, also technically, but it also needs governance, obviously. But what have you done in the UK to, as you say, at least slow down the fragmentation? Is it just that the politicians now kind of understand more, or is it have you as researchers or providers of data been lobbying hard to turn that process around, or is it what's behind kind of this more kind of or less fragmented world we live in now in the UK?
Well, let me go first, Emma. Basically, the data controllers want to retain control of the data within their own institution. You have to work hard to get them to share their data. Okay. When they do, they then see the benefits of it. But the initial persuasion takes a lot of persistence and a lot of pressure from funders. So, for example, you saw on our dashboard, on the left side, the graph, the horizontal bar graph of the access requests. Well, the point is the funders can see that. So when they come for renewal, it's not a matter of saying, yes, we shared our data. The funders just go to our website and say, oh, yes, 175 access requests. Whereas another cohort might have 3. And if the funders asked us, we could then compare access requests versus access allowed. Okay, so by making the performance transparent, you improve the performance remarkably.
Yep. And I guess also as a researcher, you see within the field of AI, many citations are to kind of the data sharing part. It's also by sharing data, you obviously also get a lot of citation, which is also money for a researcher in a sense.
Yeah.
Yeah, I think, Emma. Yeah, please.
Sorry, Clark. I just add to that. I think the use of the hubs has been really important as the funders are starting to realise, well, these hubs are here. We're not having to fund the infrastructure twice. We're not having to put the management in. They're actually, people are going to say, oh, we want to do a motor neuron disease collection. They'll say, well, go speak to DPUK because they've already got that infrastructure in place. And because they retain their identity, it works really well. So, but you haven't got the barriers, you haven't got the silo then. The data is all becoming, everything neurological is in these areas. So again, it slows that hundreds of TREs down and opens that data up a bit wider.
So maybe also one advice is actually to expand on what is already working. I mean, in Norway, as I said, we try to do something new. We try to build a new platform, but that's the health analysis platform. But right now, for example, TSD, as we have heard here in Norway, is actually working. So maybe in Norway, then the direction should be to expand on that and try to unite.
Yeah, I think one of our big advantages is that TSD is very general purpose. So basically whatever you want to do on TSD, you can, which has meant that a lot of people who sort of, okay, we need somewhere to put our sensitive data or work with it. TSD is there and you can do whatever you want. And of course, the general approach also has its disadvantages. It means that if you don't already know how to process your data, you don't always have the same ready-made tools. But the advantage is, again, that you can just bring whatever you already have on your personal system. You just bring it in on a container, you spin it up, and you're up and going. And lately, we're also working more and more. We already have data sharing included between projects. So you only, of course, you yourself have to figure out your data sharing agreements with other projects that are on TSD. But since both are on TSD, the entire sensitive data protection and everything is already figured out. So all you need to do is sign with another consortium partner, whatever it might be. And then you have a data sharing agreement, and then we have a data processing agreement with everyone so that we actually are allowed to store it and so on. But then you can just share that data and results on site on TSD. So you don't have to export things, bring it over to another system or whatever. So that means that is already on TSD, and we're also working on ways to make that more automatic and simpler. And yeah.
Excellent. Ira.
Yeah, and another issue is the so-called sharing of data. It is still very often researchers experience that they own their data, or the hospital has a feeling of owning. It is still not enough in the consciousness that you do not own data. Data is something you are obliged to share. And if the purpose is different of analyzing data, I think there is no conflict why not ongoing projects can use already ongoingly collected data together. It should also there more strategic thinking from the governmental perspective come into place, that it is unethically to own data. This is because in hospitals, also doctors think they own their patients still. Yeah, but I'm not in the ownership with my body of a doctor. I am owning my data, and I contribute with my data to the research community, and I wish that my data are used. So for me, it is personally more important that my data are in work than that someone is gathering my data. So there needs also something be done with the attitudes we are govern our data. It is still very project-based. It's not which kind of data exist. It should be more again, the knowledge graph should be more interactively usable, user-friendly. Knowledge graphs are very often very complicated to read. and very boringly to read. So we should make them a little bit more sexy, a little bit more commercializable in a sense, so that people are really understanding what is available.
So, Ira, if I could just comment on that, I honestly think it boils down to clarifying the property rights. And in one sense, the property rights don't have to be perfectly defined, but they have to be clearly defined, because then people will work with them. And biobank is a good example. The property rights are draconian, but everybody knows how to work with them. You know, and I completely agree. To have John Gallacher pretending he owns data is a travesty, complete travesty. But somebody, and I think a government, and the UK has been so reluctant to do this, you know, a government needs to sit down and say, these are the property rights for publicly funded data.
Yes.
Okay?
End
of story. End of story. And then people will, in the first year, they'll create a fuss, okay? Outrageous, how dare you, blah, blah. After that, they'll get down and they'll use it.
Yes, I totally agree.
Totally agree. We only actually have 2 minutes left. So I don't know if we should conclude with, I mean, the title was collaboration. So just a short note and end note from some of you, hopefully, on how to proceed. What's your vision, Ira? How to proceed with the collaboration, UK Norwegian collaboration?
Yeah, in the first step, we wish to make us available for the UK, so that we would work on this federated integration of our node into the UK biobank, also dementia data bank. And then another aspect is that we wish as soon as possible to invite to a hackathon, so that the UK researchers in this field make them available their knowledge to solve the problems we can't by manpower alone solve. So that would be the first step very soon, and I would wish that John and Emma would have with us as soon as possible a meeting, also with Klaas and Ainar, and then we could agree on a date, on a period. We make our open our gates and invite a collection of researchers to access prospectively highly sensitive data, helping us solving a problem.
Hackathon is...
We'd be delighted for that, Klaas. Delighted.
Yeah. So do you have a final closing remark, Emma or John, on that, or general on collaboration, dementia?
Emma?
Well, I just say it's wonderful what you've created and the work that you brought in to be able to open it up for AI thing. I love the way you've got your data together, your access similar to ours, but slightly nuanced differently. I think, you know, just even understanding a little bit more around that infrastructure, the technical sides, how we've set up, that'd be wonderful and I think we could both benefit from knowing what the others are doing in that area. So just even getting to know your platform more would be great.
Or automated file outs.
Yes, if someone could get on that'd be great.
Yeah, maybe then Ainar, we send an invite for a next meeting, a technical meeting between us, and then we agree together with Glass and the community of AI researchers in Norway and in the UK how we do that and when we have this hackathon.
Excellent.
Okay.
Yeah, on TSD side, we're always happy to talk with other sensitive data storage and processing environments as well. And especially on the technical side, there's always more to learn on both sides, I think, and having technical coordination and talks there would be very nice as well. And that would also play into the federated part and creating links and seeing how we can do that in the future.
That's great.
Excellent. Sounds like we have a good plan for collaboration. Thank you, everyone, for your excellent talks, and thank you to the attendees. And this will all be also put out on YouTube, so this is recorded for others. yeah, have a nice day. Goodbye.
Thank you,
Thank you very
Klaus.
much.
Bye, and thank you so much.
Thank
Thank
you
you.
so much.